Good morning all. The topic of my seminar is a study of voice recognition techniques based on machine learning methods. Speech recognition is a system that translates spoken utterances into text. Now, these text can either be in the form of words, word sequences or syllables. So basically, it's just translating speech into its corresponding text form. The development of a good ASR system is very desirable because it has a lot of advantages. A person can save his or her time, which is mostly spent used in typing. So rather than typing, he can speak to the devices. There is another kind of socially desirable aspect of building a good ASR system. As we know, the present technology has interfaces. So, if an automatic speech recognition system is built into the interfacing device, then it can be used by both literate and illiterate users. So, even the users who cannot read or write in a particular language can interact with this technology if it's voice driven. Now, some of the well-known examples you may be familiar with are YouTube's closed captioning. It has an automatic speech recognition engine running. It actually produces the corresponding transcripts for speech, audio, and video clips. Siri, Cortana, Google Voice, all of their front ends are automatic speech recognition engines. Now, let's take a look at the objectives. The first objective of the seminar is to identify and present the most suitable speech recognition method for the project. The second objective is to analyze the speech-to-text summarization process. The third objective is to identify the problems related to speech recognition technology. Now, let's see the basic principle of voice recognition technology. This is the block diagram of a simple speech recognition system. The first stage is to record the speech signal from the user and pre-process the signal. Here, in pre-processing, we aim to suppress the noise and other channel effects. Next is feature extraction. Feature extraction is where the features are extracted from the input speech signal. The purpose of speech extraction from the input speech waveform is to characterize it at a lower information rate for further exploration. The most widely used feature extraction technique is Mel frequency substral coefficients or MFCC. Now, the system establishes a voice model according to the characteristics of a human voice. Then, it analyzes the input voice signal and extracts the required features on this basis in order to create a required template of speech recognition. Now, a speech recognition method is used to compare the voice template which is stored in the computer and the characteristics of the input voice signal. Search and matching strategies identify the optimal range of the input voice match with the template to produce the recognition results. I hope that's clear. The next topic is speech recognition methods. Here, I will discuss three most popular methods of voice recognition. The first approach is dynamic time warping method. The next is hidden Markov model approach. Then, speech recognition using CNN. So, dynamic time warping. Dynamic time warping technique compares words with reference words. It is an algorithm to measure the similarity between two sequences that vary in time or speed. In this technique, the time dimensions of unknown words are changed until they match with that of the reference word. It basically involves two steps. In the first step, a distance matrix is created, and using this equation, the elements are filled in the matrix. In the second step, an optimal time warping distance is calculated. Now, let's take an example for better understanding. Suppose there are two time series A and B, and both have 10 elements each. So, first we create a 10 by 10 matrix, and values of both the time series are plotted against the two axes. Let's see how we got this element 11 here. The corresponding AI value for this element will be 9, and its corresponding BI value will be 3. Their difference is 9 minus 3, which gives 6. Now let's keep this value aside, and now we have to compare these three values, 11, 5 and 5. So the minimum among 11, 5 and 5 is again 5. So we add this 5 with the 6 we got earlier, and now we'll get 6 plus 5, 11. So likewise, we will fill the entire distance matrix. The first step is over. Now we need to find the optimal path. Once we fill this entire matrix, we begin from the top right corner. From here, we will choose the least element among the surrounding three elements. And we repeat this step till we reach the element which is present in the bottom left corner. So that's how we find the best alignment between these two time series. The smaller the value of the distance produced, greater is the similarity between the two sound patterns. So this is dynamic time warping method. Now let's move on to hidden Markov model. In this method, speech is split into smaller audible entities, and these entities represent a state in Markov model. Now, according to the probabilities of transition, there exists a transition from one state to another. Now let's see the steps. The MFCC coefficient matrices are transformed into several states and transients. Then they are reformed into sequential probabilistic models. Now HMMs have an initial steady state, the probability of which is the initial probability. Then we have, this is actually represented by pi. Then we have probability of transition from one state to another, and this is called transition probability. This is represented by capital letter A. And additionally, we have observation probability, and this is represented by capital B. In these equations, n represents the number of states, and the states are denoted by set Q, and m is the number of distinct observations, and it is denoted as set 0, set O. From these, HMM can give the observation sequence for the entire model as lambda equal to A, B, pi, and this will specify the complete parameter set of the model. Then we will use a forward-backward estimation algorithm to train its parameters and find the log likelihood of the voice sample. Then Viterbi algorithm is used to select the one with maximum likelihood, which is nothing but the recognized word. Now let's move on to CNN, how voice recognition technology is implemented using CNN. So first let's talk about layers. Convolutional layer is created by convolving signals with a bunch of filters and a bunch of features that creates a stack. We get a lot of filtered signals because of the presence of filters. Next is pooling layer. Pooling layer reduces the size of the filtered signal. The third part is normalization. In this, if a value is negative, then the negative values are replaced with zeros. This is done to all filtered signals. This becomes another type of layer and it is called as rectified linear unit. Now, a stack of signals becomes a stack of signals with no negative values. Now, these three layers are stacked up, so the output will become the input for the next. The final layer is the fully connected layer. Next is 2D matrix representation. The first step is to provide the fragments in a two-dimensional matrix. The filters of the first layer start recording for two-dimensional values simultaneously, and these recorded values are then combined in the next higher level layers. Now let's see the activation functions used. In the first convolutional layer, we use tanh function. In the next two layers, we use rectified linear unit. Now this is an experimental analysis. An automatic speech recognition based airport enquiry system has developed natively for Telugu language, and the total words trained for the process of recognition are 583, and the total phoneme count resulted is 1765. Now these are some distinct phones, and the database is based on the most frequently asked questions in an airport enquiry. I have put a question right here. Likewise, there was 4 or 5 questions which was in the paper. Now these are the results. The similarity metric of each phoneme is given. From this, it is concluded that the performance of an ASR, which is automatic speech recognition, based on CNNs, which actually takes raw speech signal as input to do a large vocabulary task. This has proved that CNN-based system is able to achieve good performance than traditional techniques-based system. Next topic is speech-to-text summarization, and this actually is a two-step process, and the first step is important sentence extraction. The formula is S of W equal to 1 by n sigma t equal to 1 to n L of Wi plus lambda 1 into I of Wi plus lambda c into c of Wi, where n is the number of words in the sentence W and L of W is the linguistic score, I of W is the significance score, and C of Wi is the confidence score of the word Wi. As you can see, there are lambda I and lambda C. These are weighing factors. Now, why do we need all these scores? These scores are useful because they help us to determine if a particular word must be included in the summary or not. Next is sentence compaction. So in the second step, all these important words are concatenated. A word concatenation score, which is T of Wi, Wj, is given for every combination of words within each transcribed sentence. This score is a measure of dependency between two words. It is obtained by a phrase structure grammar, stochastic dependency context free grammar, SDCFG, and a set of words that maximizes a weighted sum of these scores is selected according to a given compression ratio, and they are further connected to create a summary using a two-stage dynamic programming technique. Now, specifically, each sentence is summarized according to all possible compression ratios. Then, the best combination of these summarized sentences is determined according to a target total compression ratio. So, this is all about speech to text summarization. Now, let's move on to limitations of voice recognition systems. So, building a speech recognition system is quite difficult because it faces several sources of variabilities. And the first one is style of speech. Just the style of speech can have a lot to do with the performance of ASR system. Rather than continuous speech, isolated words are much easier for automatic speech recognition systems. This is because in continuous speech, words are flowing freely into one another. Now there is a phenomenon which is called co-articulation, which means the preceding words affect the words that are coming and so on. So this particular phenomenon becomes a really big challenge for automatic speech recognition systems to handle. And the other source of variability is environment. Now, if a person is talking in a very noisy condition, or if the acoustics of the rooms are very challenging, for example, it's very reverberant, like a lot of echo is there, or you could be speaking in the presence of interfering speakers. Now, background noise can also be of different types. Like if it's the noise of vehicles, then it can be isolated to an extent. But if it's the noise of people talking behind, then that's a real killer for automatic speech recognition system to pick the foreground voice. So that is one of the major challenges. Next is speaker characteristics. Now, all of us have different ways of speaking. So, accent comes into play, rate of speech comes into play, and as we all know, different people speak in a different way. For example, some people speak faster and some people enunciate more, and age also comes into play here. For example, a 5-year-old and a person in 60s speak very differently. So these all depends upon the characteristics of the speaker. So the automatic speech recognition system must be able to be robust. Finally, task specifics. There are a lot of task constraint specifics, like the number of words in the vocabulary you are trying to recognize. For example, in case of voice search applications, they are actually looking at million-word vocabularies. But if you are looking at a command and control task, there the vocabulary is much smaller, so the task is much simpler. So this is another variability. So these are the limitations of voice recognition system, and now the researchers are continuing to make a robust automatic speech recognition system. Now, coming to conclusion, so in this seminar, the basic principle of speech recognition technology was discussed. Then, speech recognition using three most popular methods: dynamic time warping method, hidden Markov model, and CNN was explained. Then, a two-step speech-to-text summarization was also covered. Then, limitations of speech recognition technology was also discussed. Now, as per the objective 1, I have chosen a dynamic time warping method to implement the project. This is because our project involves command and control. That's why, so in DTW, it is actually well known for such cases because the vocabulary we are trying to refer is much smaller and the grammar is constrained. So that's why I chose DTW. Now, these are the references I used to present this seminar. So that's all for the seminar. Thank you. Have a nice day.